In this section of the video, I'm going to show you how the equipment that we have works. Okay? So I have a pressure sensor that is hooked up to the CAS. This pressure sensor will detect the pressure that is being emitted on the system based on however else we arrange it. In this case, we have a syringe onto the pressure sensor. So we have a syringe onto the pressure sensor, and that pressure sensor goes and it gives us a reading. And we can see right now that the reading is 98.8. Now, on the pressure sensor, there's a gauge that I can point at another location, or one of 3 different locations. Wherever this gauge is pointing, that is what is closed. So, right now the syringe would be closed. If I moved it down here, it's closed to open air. And if I move it this way, it's closed to the actual pressure sensor itself. So I could move this all I want, and all it's doing is sucking air in and out of that hole that's right there. Cool. Now we're ready to start our experiments. Okay, in this section of the video, what we're going to do is we're going to set the number of particles that are inside of here the same, and then we'll modify the volume and see how pressure reacts. So to do that, I'm going to open it up to the air. I'm going to slide this to about 10. I'm going to flip it to close the syringe itself and allow the air pressure to calibrate to room temperature. And now I'm closing it to the outside environment. And now we can read the data here and the data over there as things and situations change. So, okay. At 10, it's 99. I'm going to pull it out to 15. I'm going to let it sit right there, but at 15, it looks like it's 68.5. I'm going to pull it out to 20. At 20, it looks like it's 52.7. I'm going to push it in to 5. At 5, it looks like it's 180.5. And now I'm going to try to get this down to 2.5. And at 2.5, it's 291.6. And now I'm going to let it kind of just ease its way back out. So that was 1, 2, 3, 4, 5. 5 different data points that now you can plot and see if you can find a relationship between the volume and the pressure. In this version of the experiment, what we're going to do is we are going to change the number of particles inside of here, but we're going to keep the volume constant. So how we're going to do that is we're going to take many points where we will change the volume initial, set the whole system back to equilibrium again, and then I'll keep on pulling it out to the same value. So the one that I'm going to initially set it to is going to be that 2.5, okay? So I'm just showing you I'm setting this to 2.5. And then I'm going to close it off, let the system equalize. And now I'm going to pull it to 10. And at 10, I'm reading 32.6. So I'm at 10, 32.6. I'm going to open the system again. We're going to set it to 5. Equalize it again. And we're going to pull to 10. And I see 54.8. 54.8. Okay, I'm going to open my system again. I'm going to go to 10 itself. I'm going to let it equalize, and I'm going to pull to 10. Well, okay, nothing has to happen. At 10, it's 98 or 99.0. I'm going to open the system again, go to 15, equalize it, and then I'm going to push this down to 10 from 15, and I'm at 140.6. Open the system again, go up to 20, equalize it. Okay, so now you see I'm at 20, and then I'm going to push down to 10, and it's 185.5. So there are 5 data points, 2.5, 5, 10, 15, and 20, that you can now create a graph to try to tell the relationship between number of particles to pressure. All right, this is a slightly different setup than the other labs are. So for this one, instead of having the syringe on the pressure sensor, we have a flask attached to it. That's so that we can keep the volume constant. We also have another probe set up to our cast right now, and we have a temperature probe set up to the cast. So we're going to take some data points. We're going to take data points from this cold water. We're going to take data points from this hot water bath, and we're going to take both temperature and pressure. So right now, just to show you here, we have this set up. I'm going to equalize it to everything. I'm going to push the valve that way, and then I'm going to push the valve all the way back, and then I'm going to close it to the outside air. So now the pressure is reading whatever the air pressure is right now, and the temperature is reading temperature because this probe has been sitting out for a while. So we see that for room temperature and pressure, we are at 26.7 and 98.6. All right, we're going to go to cold water first here, and I'm just going to stick the probe in and stick the flask in. Okay. I'm going to move these two around until we reach a nice steady state for both pressure and temperature. And it looks like there's no more motion happening. So we're at 91.7, we'll call that 91.7 kPa, and 1.4 degrees C. So I'm going to pull these out, and now I'm going to put the temperature probe in the hot water bath, and we'll stick this in here as well. And I'm going to hold this on to the top just in case. I'm going to wait until we're at a nice steady state again, just like with the other one. And it looks like the thermometer has hit steady state at 66.2. All right, it's because the hot plate's still on. But let's take this as our data point. 108.1 and 66.5. 66.5 and 108.1. So there was a room temperature, cold water bath, and a hot water bath. Now you can graph that and see if you can find the relationship between pressure and temperature.